Okay, so let's say we're going to graph a little bit more advanced polynomials. Let's say we're going to graph something like x cubed minus x squared minus 6x. So we do already kind of know the end behavior of this. Because my highest degree is an x cubed and it's a positive x cubed, then the graph is going to resemble what a general x cubed graph looks like, which means it's going to go to left and down, to the right and up. So we know that my graph should resemble that. It may not be that. It may go something like this, but we at least know what the end behavior is going to look like. Okay, so let's see if we can graph this. And to graph this, we probably want to get some points. So we're going to go ahead and try to find, well, the points that we've pretty much always been trying to find, pretty much the intercepts. So intercepts are your zeros. So we're going to sub some zeros in. So I'm going to go ahead and sub 0 in for my y, where my f of x is. So 0 equals x cubed minus x squared minus 6x. And now I'm going to try to solve this, well, like I've pretty much tried to solve quadratics or other high degree equations. I'm going to try to factor it. And if I look at this, I got an x cubed, an x squared, and an x. So I'm going to pull out an x. If I pull out an x, I'm left with x squared minus x minus 6. And that equals 0. So I'm going to see if I can factor this some more. This is a quadratic. It's a quadratic with an x and x. So x, things that multiply -6 and add to -1 would be -3 and +2. And that equals 0. So I get x equals 0, 3, and -2. Okay, you can probably find my other intercept. Y equals 0 minus 0 minus 0, so I have my other y-intercept would be 0. So let's see if I can kind of try to graph this out. I have some intercepts. I have x equals 0, x equals 3, and at -2. And I also know the end behavior of my graph. And the reason we kind of want the intercepts is it kind of tells us, gives us an idea of where the graph would be between them. So if these are my only intercepts, my end behavior is going down on my left, then from this intercept I have to be going down. If I was going up, then at some point I'd have to turn around and go down because that's my end behavior. But if I turned around and went down, I'd have another intercept. So I know from here that I have to be going down. I also know here that this is my last intercept, I have to be going up. Otherwise, again, if I was going down, it would come back around and cross that x-axis. So this has to be going up. So I have two parts of my graph kind of filled. So I want to go ahead and figure out what is it doing between this. Is it maybe going up? Is it maybe staying down and going like that? We're not really sure. So I'm going to do what we did with inequalities and do some test points. I'm going to put in a -1 and I'll put in a 1 since those seem to be good test points. So if I do a -1, I'm going to sub them into my factored form. So my x minus 3, x plus 2. So if I sub the -1 in, then if I sub -1, I'd get negative times -1 minus 3 is -4 times 1. So I'm going to get a +4. So at -1, it's all the way up to +4. Which means this entire thing has to be going up. Okay, so again, it couldn't have crossed anywhere. I'd have another intercept. So now let's try to put in something on the other side. I'll put in a 1. So I'll get 1 times 1 minus 3 is -2. 1 plus 2 is 3. So I'll get -6. So this is all the way down to 1, 2, 3, 4, 5, 6. 6. Make it a little bigger so it's actually where the 1 was. So this is going down here. And since it's a polynomial, I can look at this and say my domain is continuous. I can put anything in there, which means there should be no break. So I should have a smooth line. Okay.